Assalamu alaikum. Can you hear me?
Walaikum salam, yes, sir.
Okay, so then I will share my screen and then we can start today activity. So my screen is also now visible.
Yes, sir.
Okay, so let's start today activity. Uh, is there any question related to yesterday activity? Okay, if not that the case, so let's start with today activity and later on, if there is any question from any participant, so then we can take that. But let's start today activity, and so you should open R and R Studio, and I already open. Uh, so just like yesterday or the previous classes, so I will open a new R script file, and then we'll save it. And we'll give it today class name. So it's today's class 6. So I will give the class 6 name and then save it. So then whatever activity or whatever I write here, so it will save in this file. So let's directly start today activity, and tomorrow we can summarize this week work. So today we will discuss another important statistical parameter for data analysis and data visualization, and it is called correlation. So the question is, what is correlation, or why we perform correlation? So let's first discuss this, and then we can go for data analysis and data visualization for correlation, or for determining correlation, or what package we can use to determine correlation. So correlation, is the name indicate, co between two things, and relation. So in any statistical analysis, so we are usually interested to determine the relationship between two variables. So variable are any parameter in which measurement we are interested. So if I open this, so the variable are these different columns in our data sets. So age is one variable, gender is another variable, and the other variable, or the different variable, are shown in a different column. So in correlation, we are interested that what is the relation of one variable with another. Let's say, what is the effect of age on the plasma osmolality, or what is the age of gender on plasma osmolality. If we are interested to do this, or if we want to do this, so we have to use or we have to determine the correlation. So correlation used to determine relationship between two variables, and variables are usually shown on different columns. So the relationship between two variable, it can be of different types. So but the most common is, it may be positive relationship or positive correlation. So how is positive correlation? When one variable is increasing, so the other variable also increase. Let's say this is a graph, if we put the data for one variable on the x-axis and for the second on the y-axis, so if the data of x, the variable which is on the x-axis is increase, so the measurement of the variable on the y also increase. Like, so this, when a relationship is just like this, where one increase in one variable also lead to increase in the other variable, so this is called positive relationship. Or when one variable is decreasing, so the other also decrease. So this is a positive relationship. This is one type of correlation. The second type of correlation is negative. Negative correlation, when one variable increase, the other decrease. When that is totally opposite. So how this will be in the graph? So if this is a graph, and if the two variable, they have negative correlation, so let's say if the one variable value is high, the other, or when the value of one variable increase, so the other variable value decrease. So this is the y value, and this here is the x. So when the x value is increasing, the y value decreasing. So this is a negative correlation. The third type is zero correlation or no correlation. That will be when change in one variable has no effect on the second variable. So how in graph, this will be no correlation, zero correlation. So let's say this is the value of one variable. Oh, sorry. I will clear my. So the no correlation or negative correlation will be this. When one variable value is changing, there is no effect on the second variable. So this is zero correlation or no correlation. And usually in correlation, whenever we want to measure correlation, so it will be either positive, either negative, or no correlation. So these are the three options. And the positive correlation, the maximum value of positive correlation is +1. So whenever we determine correlation, so the maximum value will be 1, or it will be between 0 to +1. So the positive correlation value will be from 0, like above 0, till 1. Negative correlation value will be -1 to 0, minus 0.1, in between this, and the 0 value will be like 0. So whenever we determine, so it will be in between this. Now the question arises how we will determine. Let's say we have these variable, like in our data sets, these are the different variable. There are variable in this, there are variable in this file. And if we want to measure the correlation between these, so how we will do? So now let's go to here. So how we can determine the correlation between two variables? So let's discuss the packages which we can use to determine correlation. So it is like one of the important parameter whenever we get some data. So we are interested that if we have multiple variables, so we want to determine that if we when the value of one variable change, increase or decrease, so how it has any relationship, it has any correlation with the other or not. So for that we do the correlation analysis. So the packages we use for correlation analysis, packages for correlation analysis. So there are two package most commonly used for correlation analysis. One is called core plot. So this is one package. There is another package which is also commonly used for correlation analysis, that is called psychology. So these two package, they are used for correlation analysis. So let's first install these packages and then we can perform correlation analysis for our variable or for a variable in our data set. We can then do the correlation analysis. So first, whenever we want to install a package or we want to check whether we have a package or not, so we have to click on the packages in the screen or in panel 4, and here you can check, like let's check the core plot. So I already have this core plot, but you should install. If you don't have, so how you will do? You will click on the install button and then here you will write core plot. So write this core plot and then install it. And then when it's installed, then confirm. So then we can go to the next step. So install core plot package. Okay. So, okay. So now you have installed the core plot package. So we can go to the next step. We have to turn on. So after install, you can also install the psych package. So also install the psych package. Then we can start activity first with the core plot and then we can later do it with the psych. So install this psych package and then confirm. So then we can go to use these packages. So write psych and install.
Okay, one question, sir, that how
Yes.
we know that our package is installed? Are it is shown in the R console?
Yes. So when we turn on it, like when we library it, and if we show, I will show you. So when we install a package, so then one confirmation we can do, just like here, I click and we can write the name of that package here in this search window, like let's say the psych. If we see here this option, so this means that this package is already installed. So one option is here. You write here the name of the package, and if you see that it appear in the screen 4, so this confirm that this package is present. The second way is we can write in the script here. library, the name of the package, let's say core plot. And when we run it, and if we get this library core plot in blue without any error, so this means that this package is installed, or this confirm that the package is installed and it's turned on. Okay, so in these two way we can confirm. Okay, so also install the psych package. Okay, so now we can start activity with the core plot. Okay, so first of all, we have to turn on the package, the core plot. So we are going to work on the core plot package. So library it's just like I did library core plot and then run it so that this package turn on, and then we can start working on it. So when we library it, so then we can go. So there are two things. As I mentioned that whenever we do correlation analysis, so first we have to determine the correlation value. So the correlation value will be between +1 and -1. So we have to determine the number or the value of the correlation analysis, and that is shown in the form of table. And the next, then we can go for making a graph out for that value. So let's first determine the correlation value, and for that, or for determine the correlation value, so we use the function which is called core function of the core plot package. So we write core, and then we enter the name of data file for which we want or for which we are interested to determine the correlation analysis. So we have these three data file, ABC1, where there is data of health, ABC2, where there is a data plant, and ABC3, where there is data public administration. So let's do for ABC1 file. So ABC1. We enter the name of date. So now it's depend if in our data all the variables are in the form of numbers or numericals, like this is a numeric. When we just put cursor on this numeric with range, it showed numeric with range 260 to 310. This one is also numeric with range 136 to 147. So these are all these variables are shown in the form of number. But if we click on this, the gender one, so it's a character column. So you should keep in mind that we cannot do correlation analysis for a variable which is shown in the form of characters. So like this is a character data. So we cannot do correlation analysis for this variable. And we can also check the other variable in our data, but other are like the other variable, they are in the form of numbers. So therefore, we have to exclude that variable where the value is in the form of character, where there is no numerical data. In the same way, we can check the other data file. So here, if we put cursor, so this variable, the time point, is also character. So we cannot do correlation analysis for this. But the other variable, they are numerics. This one is also numeric. And this species one is also non-numeric. So we cannot do correlation analysis. So now let's go to activity. So if in our data only numeric variable was given, so we will get the correlation value. If just one variable is non-numeric, so then we will not get. So let's run it. So we get error, and it show the X must be numerics, or the data for all variables should be numerics. So for non-numeric, we cannot do. So therefore, now we have to exclude those columns. Like this column, we should exclude, then we will able to get the correlation value. The same way in this data, we have to exclude the column 1 and column 6. From this data, also the column 1 and 6. But let's do first for the column for this data file, where which column is non-numeric. So the column 3, the gender one, male and female one. So we have to exclude. So one way is to manually delete this file. Not file, not just this column, and then again upload. So that is a lengthy process. We can also do in a simple way. So it's like when we did or when we run this, so we get this error. So now we have to exclude. Whenever we want to exclude a column from our data, so we have to write the number of that column. So this is column 1. This is, if you like put cursor, so it will show that this is column 1, this is column 2, this is column 3. So this means we have to delete or exclude column 3 from correlation analysis. So then we will able to get a value. So core, we define our data. So now we have from this data, we have to exclude the column, one of the column. So column, whenever we want to add or delete a column, so we have to add this large bracket sign. The large bracket sign is just above the enter button. So we do this, and then we can enter. If we have one variable which we want to exclude, so we have to write the number and then the number of that column. So in this data ABC1 data file, the column 3 is non-numeric. So we write the number of that, and then let's run it. And we can see that we get the correlation value or not. So we get now a correlation value. So everyone, you should repeat this and then confirm that you get correlation table. This is a correlation table. I will copy paste in the WhatsApp group. So you should also repeat and then confirm that you get the correlation table or not. So it's like usually there is Asia. Sometime in two package, some of the analysis they overlap. So when you activate, like let's say yesterday we was using the ggplot2, so that was activated. Now you activated the psych package. So when the psych package is activated or when you are using the psych, so it will mask those package where there is overlay, but it will not affect your analysis. It will just mask those things. So, but it will not affect, it will not give any error. Is it clear? Okay, so everyone did the correlation, get the correlation table? Just confirm that you.
Yes. Done.
Okay. So everyone should confirm that you get the correlation table, then we can go to the next step.
Yes, got it.
Okay. So now let's continue. So now if you look at this table, so as I mentioned in the beginning that the correlation value will be between +1 and -1. So in this table, all value are in that range. Like the maximum value is +1 and the minimum value will be -1 and all the other will be in between that. So in this table, the different variable value is given. So this is like subject versus subject 1, subject ID versus age. So this is like not important the ID, but the other parameter, age versus age, age, plasma, osmolality, this one, the other variable. So the correlation for all variable is shown, and from this we can say that which two variable has positive correlation, which has negative, and which variable don't have any relationship. Okay. Now we can go to visualize this table. Like in this data we have, like when we exclude this, so the remaining like 7, 8 variables table is shown. Sometimes we may have 20, 30, and we will get a large table. So now how to visualize this table or how to visualize this correlation table? So we will go, so this is like the analysis of correlation. Now we can go to visualize it. So when we visualize something, so then we can read it more easily. So usually in publication, the correlation table is given, but along with that, correlation graph is also given. So now how we can make a correlation graph? So to make a graph for correlation, we use another function within this core plot that is called core plot function. So this core plot, like for correlation table, COR function is used. For visualization, core plot function is used. And we want to make this plot for what? For the correlation table, for this table. So within this bracket, now we have to write this. We can copy paste, or we can also write the script for the correlation table. So core bracket ABC1, then the large bracket, and we have to exclude the non-numeric column. We write that. So now we write this script for the correlation table here. And now we can run it. And in this way, we get this correlation table, correlation graph, where this table of correlation is shown in a form of graph. So these are the variable, and these are one variable against the other variable. So some are shown on the x-axis, some are on the y-axis, and the strength of their relation is shown by color and as well as by the size. But this is correlation correlation graph. So I will also share this within group. So first was correlation table, now it's a correlation graph, and then we can move on to further increase, or we can make other type of correlation plot. So just everyone confirm that you got
This
this.
is positive correlation.
As I mentioned, if you look at this table, so there are some are positive, some are negative. So where minus is written, so that is negative. And if you look at this graph, so I will zoom it. So here is the maximum is one value. So this means the dark blue show where there is positive correlation, and where is the red color, so that show a negative correlation is below the zero. So these, where there is red color, so that is negative correlation. But we can see everything within one table.
The
Is it
color
clear?
of these, yes, it's clear. But the color of dots is very fade. Can we make them dark?
Yes, we can change, but this is like the default version. But we will go and do the other type, and there we can change. But this is like the default version. Here
And
we
I
this is the
suppose
the simplest one. But when we go to the further details, so then we can change it.
And I suppose these are faded because the degree of correlation is inferred by the intensity of the color. Because if you
Yes.
see urine osmolality is positively correlated, and the correlation, if you see these graphs, it comes around between 0.6 to 0.8, somewhere between 0.6 to 0.8.
Yes,
However, if
exactly.
you see the lighter ones, the subject ID for suppose, it is near to zero.
Yeah.
So
Yes.
probably it is like
Yes.
that.
Yes. Exactly. You're absolutely correct. So this, like the light blue, it show that the value are near to zero, but they are positive. When it's light red, so that is negative, but near to zero. And when it's dark, so that means it's near to -1 or +1 for the dark blue. Okay, so it's clear. So now we can go to make other types, and then you will understand further. Okay. Okay, so now we can, like this is just one type. Now let's play with it and make other type of correlation. And then you can you can decide it based on literature or your research group. So if they prefer a specific type of correlation graph, so then you can make that, or you can also select a correlation type graph from publication of your field. So let's do other type of correlation plot. And okay, so now we can just copy paste it and we will try to improve it. Okay.
Can we find correlation between only two variables?
Yes,
But suppose we can, right?
Yes, exactly. Like right now, I write the name, the name of the file. If let's say if we want to do manually, so we can enter that here. If you remember, we was adding manually data here. Like this is one variable X, and now we can add another variable Y and its value. Let's say its value is 11. Like you can also enter the actual value, but I just want to show you that how we can do it manually for two variables. So this, now we can do it core X, Y, and then we can run it. So we get this value, which is 0.98. So this means when one variable is increasing, the other is also increasing. So it's give almost one
Positive
value.
correlation.
Yes, and
okay.
if we do in opposite way, so then it will give a negative value. And I also get your other question, so we can do in data table also this. So now let's run this when it's opposite case. So now it will give -1 value here. -1. Now, if we want to do it in our data table, so we have to exclude all other, and then we can leave just two variable, and then we will get the correlation table for those. Let's make that also. So how we will do that? I will clear this. Here we just exclude one variable or one column. If we want to exclude multiple columns, so then we have to enter the name of those. So minus, whenever we want to enter multiple, so we have to write C, and now we can write the number of column. Let's say we want to exclude the column 1, then also column 2, also column 3, also let's say column 4, also column 5, whatever number we want, and let's leave the other column, and now we can enter. Okay, no, sorry, first we have to do this here. When 1, 2, 3, 4, 5, then let's check. There is some, sorry, C. Okay, so in this way now we get the correlation table for few variables, like now 3, 3. If we exclude one more, so then it will be for 2, 2. You get it?
Yes, I got it. Thank you so much.
And we can also like now make plot for this. So we can close it and break it and write the core plot. See, you can play with it and so that you know that what we can do and what we cannot do. So now this is for a few variables like per 3. You can further reduce to 2 or 1 by adding the number of column which you want to exclude. Okay.
Okay, got it. Can you tell me what are these dark blue circles
Dark blue
representing?
yes, they are the maximum, like where the value is 1. So when you run a column, a variable against that variable, so its value will be the maximum. It will be plus because there is no change to, like, this one is the urine osmolality against the urine osmolality. So mean the two column, they are exactly the same. So that's why this is the maximum. But when urine osmolality is compared against the water intake, so it's very light. It's almost near to 0.
Zero.
So therefore, water intake against water intake is the highest, but water intake against ADH levels is negative, and urine osmolality against the ADH level is positive. So you can depict it from this figure. Okay.
Thank you.
Okay, so now we can make other type of core plot. Okay, so let's play with this one. You can do it any other, but so I will copy this and then paste it. Now, let's say we want other type of correlation plot. So what we will do, so this is like now our data. Now we want to change the type of core plot. So we write method, then equal to, then we can write the type of correlation plot we want. We want, let's say, numbers one. Let's run it. It will give an error. Then we can, but it will also give us option. So in the above script, I just add comma, method equal to, and then double comma, I write numbers. Then it give error. Argue should be one of the, like, we can make correlation plot, but if we give this option, circle, square, ellipse, numbers, not numbers without S, shade, color. So you can try this. Let's say I change the number. And then we can see how the number correlation plot look like. So this is now the numerical correlation plot. You can also now change, like the number with these options: circle, square, ellipse. So everyone should practice and see that how that plot look like. So I just copy paste, and now let's say circle one, and run it. So this is the circle one, or the by default plot which we get. So that was circle correlation plot. Now let's try the other plot. Let's change it to the square. So this is square plot. We can also try the ellipse, the color one, the pie one. So this is the ellipse one. Now, so everyone should practice on this, and let's do the color one. So this is color. And this is the pie one. So everyone confirm that you got these different type of core plot.
Yes, got them all.
Okay. One more thing you can do, let's say if we want, this is a complete one. If we want, sometime we need a half one. So we can also do that. Let's say if we want this like the upper one or the lower one, so then we can write the upper or lower, and then we will get the half one. Like here, now the half is removed, just the upper left. If we want the lower one, so then we can write that also. The lower. This is a lower plot. So, and this you can do for all of the plot which we made.
And can we get two different methods in the same?
Yeah, like we can, yes, combine
Like,
these plot.
yeah.
But the page work is just for combining the ggplot2 plot. For this, there is a different package or a different method to combine plot. Like this is a totally different package, the core plot. So we can now move on to how to combine the plot in core plot package. So there is another function within this package. That is called par. So we can use this par function to make or to combine the plot which we created with the correlation analysis in core plot. So par, and then we can write further detail. MF row, and then we can write Let's say if you want to do 1, 1 or 2, 2, let's say I will explain you that what does it mean. Okay. So we use this function for within bracket mf row equal to c and then 2 2. So this 2 represent the number of rows and this represent the number of columns. So if we want 2 rows, let's say how it will be, the row is like this way. If we want 2 rows, so we have to write 2. And if we want 3 rows, so then we can change the first number to 3. The second number represent column. So if we want, let's say 1 column or 2 columns, so then we can write the number of 1, 2, or if we want 3, so then it will give us 3 figure. So this, so now let's demonstrate this and then you will understand what I mean. Okay. So we have to write this script before the plot which we want to combine. So now let's first run this. We run this. Now we can move on to our script. Okay, it's okay. I haven't add the second bracket. Okay, so now it's activated. Now we can add. Let's say this is first row in the first plot. Now the second. Now the third. Now fourth. So in this way we combine 4. If we want to increase the number, so then we have to change this number. I will share this script. So you have to write this before your plot and then you can combine them. And then confirm that you get this combined plot.
Yes, I did get those combined plot, but my question was actually
Yeah.
that can we combine 2 separate upper and lower drawings in the same, like this is the one correlation plot,
Yes.
the whole square, and can we have upper with pi and lower with numbers and vice versa, anything in the same one square? Can we have this? Combination is combining 2 to 3 plots together in one picture, but having in one square, can we have upper and lower moieties with different methods like pi above and number below or ellipse above?
No, but that will not like give any important information. So if we want like 2 type of plot, let's say upper and lower, so then we can make them separately and then can combine or like this way. Like here,
Okay.
let's say panel 1 is the square and panel 2 and it is the upper and here is, let's say, another pi 1 or the square 1 and we can add the lower. Then we can see that which one is more better.
Okay, got it.
Okay, so everyone should practice on this. You can also, like here we combine 2 2. Now let's change it. Let's say if we want 3 columns, so we can change the number and then run it again. Now the first, second, third. These are the option. If we want to change further, let's say 3, 3. So we can do that. So you can now play with this, change it to 1, but it will further decrease. But the better one is when we have few 1. Let's say 1, 1. So this is the 1, 1 will be just 1. 1, 2 will be look like this. Is it clear? Is there any question?
Okay, as we have, yes, in par MF row, we have type, 1 and 2. That
Yeah.
means that we will get one. I didn't get the meaning of like what is 1 and what is 2. I missed it.
This one here, as I
Yes,
mentioned,
yes.
that the first number represent row. The second number represent this 2. This represent column. And as I mentioned, that row will be like if we want 1 row, so this is 1. If we so then and the 2 represented 2 columns, so this is 2 graph in 1 row. So there is in this graph there is 1 row, but there are 2 columns. When we change the 1 to 2, so this is will be the 1 line. This is like the 1 row. Second will be here. And the same way the column, this is 1 column, this is 2 column, and we can also increase. So as I demonstrate, so let's demonstrate it. No. So you can like now play with this, change the number 2. So then there will be 2. Now it will be 2 rows, like the graph which we get. So it's 1 row, 2 column. Now 2 rows, 2 columns graph. When we run this, let's first run this, or we have to exclude, like I wrote it without hash. So now there will be 2 rows. This is row 1, now it's the second row, and 2 column. Again. Is it clear now?
Okay, yes, I got it.
But you can like now change it like 3, 3, 2, 2, and then you will see the difference between 1, 2, 2, 2, 2, 3. So the number of plot will change when you change the number. Okay, so this was about the core plot. The next is psych, but I guess we can do psych tomorrow before tomorrow class activity. And you can now practice on this. You can play with it. You can make different types. You can combine the different types, and then we will continue tomorrow. And if you have any questions, we can discuss that before finishing the class.
No question. Done.
Okay. So then see you tomorrow. Okay. Allah Hafiz.